March 1943. North American Aviation Plant, Inglewood, California. Charles "Charlie" Garrison hunched over his welding torch, blue flame dancing across metal as sweat beaded on his brow. With a quick glance to ensure no supervisors were watching, he made a modification to the P-51 Mustang's wing that wasn't on any approved blueprint. This single unauthorized alteration would transform the Allied air war in Europe, extend bomber missions by 1,500 miles, and save thousands of American lives, all because one man refused to follow orders when he knew there was a better way. Within weeks, test pilots and engineers would stand in stunned silence as modified P-51 seconds shattered range projections, staying aloft nearly twice as long as the official specifications claimed possible. Charlie's illegal modification would trigger a crisis within the Army Air Force's command that would echo through the highest levels of the war effort, forcing generals and engineers alike to confront a simple truth. Sometimes the most revolutionary solutions come from the shop floor, not the drafting table. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The P-51 Mustang sat gleaming under the harsh lights of Bay 12, its aluminum skin reflecting the bustling activity of the production floor. Serial number NA102979, destined for the 357th Fighter Group, 8th Air Force, bore the stenciled inspection marks of a dozen quality control specialists. But it also carried something no one had authorized: a modification to the wing fuel junction that couldn't be seen without dismantling part of the structure. Charlie Garrison, 43 years old with 20 years of aircraft welding experience, had spent the previous night unable to sleep. The blueprint specification for the wing fuel line connection bothered him: a needlessly complicated joint that created turbulence, reduced flow efficiency, and most critically, added weight at a crucial stress point. After 3 years working at North American Aviation, he'd developed an instinct for where metal failed, and this design would fail maybe not immediately, but eventually, and at the worst possible moment for some poor pilot fighting for his life over enemy territory. The modification took him only 17 minutes to complete: a reinforced, streamlined junction that eliminated 3 separate parts and reduced weight while improving fuel flow. To anyone examining the aircraft, it appeared identical to specifications. The inspection team signed off on the plane, and by noon it was rolled out to join dozens of others awaiting transport to England. Charlie watched it go, simultaneously proud and terrified. He'd violated every protocol, risked his job, possibly even broken the law. But he'd done it because he believed it was right. What Charlie couldn't know was that his small act of professional defiance would ripple through the war effort with consequences far beyond anything he could have imagined. Within months, this single modification would transform the strategic bombing campaign against Nazi Germany, extend the combat radius of the P-51 Mustang by over 1,500 miles, and save countless Allied airmen's lives. The first indications that something unusual was happening came 6 weeks later. At RAF Leiston in Suffolk, England, maintenance crews were puzzled when pilots of the newly arrived P-51 seconds reported anomalous fuel consumption readings. Chief Technical Officer James Harrington noted that several aircraft consistently showed 22% less fuel burn than expected during identical mission profiles. Initially suspected of faulty gauges, the aircraft were subjected to detailed inspections. "These readings can't be right," Harrington told his commanding officer, showing him the maintenance logs. "Either we've got widespread instrument failure, or these planes are dramatically more fuel efficient than headquarters claims they should be." Colonel Thomas Richardson ordered a comprehensive evaluation. "Pull every aircraft showing these readings. I want them tested side by side with the ones performing to specifications. Something's not adding up, and I need answers before I report this up the chain." The testing revealed a pattern no one had anticipated. Every aircraft showing the anomalous fuel efficiency had come from the same production batch at North American's Inglewood plant, specifically from Bay 12 during the second week of March 1943. The differences were consistent and repeatable. These P-51 seconds could fly significantly farther on the same amount of fuel. News of the anomaly reached 8th Air Force headquarters, where planners were desperately seeking solutions to the bomber escort problem. The B-17 flying fortresses, striking deep into German territory, were suffering catastrophic losses because fighter escorts lacked the range to accompany them all the way to targets and back. If these reports from Leiston were accurate, they represented a potential breakthrough. Major General William Kepner, commanding the 8 Fighter Command, ordered an immediate flight demonstration. On a clear April morning, 2 P-51 seconds took off from Leiston, one with the standard configuration and one from the anomalous batch. Both carried identical fuel loads and flew the same course at the same altitude and speed. The standard aircraft returned with fuel reserves as expected in the technical manual. The modified aircraft landed with enough fuel remaining for an additional 600 miles of flight. "Gentlemen, this is not a measurement error," General Kepner told his staff after witnessing the demonstration. "Something is different about these aircraft, and I want to know what it is, why it is, and how we can replicate it in every P-51 inches Europe. And I want answers yesterday." A team of engineers from North American Aviation was flown to England on priority transport. Led by Chief Engineer Lawrence Wilson, they began a methodical disassembly of one of the anomalous aircraft, comparing each component against design specifications. After 3 days of painstaking examination, they discovered the unauthorized modification to the wing fuel junction. "This shouldn't be here," Wilson said, pointing to the streamlined fuel connection. "This isn't in any blueprint I've ever approved. But whoever did this," he paused, studying the elegant simplicity of the welding work. "Whoever did this is a damn genius. The modified fuel system eliminated turbulence in the fuel flow, reduced line pressure, and most critically, allowed for more complete consumption of fuel from the wing tanks before drawing from the main fuselage tank. The cumulative effect was a dramatic increase in effective range without any changes to tank capacity or engine efficiency." Wilson photographed the modification from multiple angles and drafted detailed technical drawings. "I need to know who made this change," he told the RAF maintenance chief. "This person solved a problem my entire engineering team missed, and I need to speak with them immediately." Back at the Inglewood plant, Charlie Garrison continued his work, unaware of the commotion his modification had created. When summoned to the plant manager's office, he assumed he'd finally been caught and prepared himself for termination, possibly even criminal charges for tampering with military aircraft. Instead, he found himself facing not only the plant manager, but also 3 senior executives from North American Aviation and a brigadier general from the Army Air Force's Materiel Command. On the conference table lay technical drawings of his modification. "Mr. Garrison," the general began, "would you care to explain why you took it upon yourself to modify the fuel system of United States Army Air Force's P-51 Mustangs, contrary to approved specifications and without authorization from any supervising engineer?" Charlie swallowed hard. "Sir, I've been welding aircraft for 20 years. I saw a flaw in the design that was causing unnecessary turbulence in the fuel flow. The way the junction was designed, it created resistance, which meant pilots couldn't access all the fuel in the wings efficiently. My modification allows more complete fuel usage and eliminates 3 unnecessary parts, which reduces weight and the chance of failure." "And you didn't think to report this through proper channels?" the plant manager asked. "With respect, sir, I did. Twice. I submitted improvement suggestions through the official process. Both times I was told modifications would require months of testing and approval. Meanwhile, our boys are dying over there because their planes can't fly far enough to protect the bombers. I couldn't let that continue when I knew how to fix it." The room fell silent. Finally, the general spoke. "Mr. Garrison, in normal circumstances, your actions would result in severe consequences. Unauthorized modifications to military aircraft are serious violations of protocol." He paused. "However, these are not normal circumstances. Your modification has increased the effective combat radius of the P-51 by over 50%. Do you understand what that means?" Charlie shook his head. "It means our bombers can now have fighter escort all the way to Berlin and back. It means potentially thousands of American lives saved." The general stood and extended his hand. On behalf of the United States Army Air Forces, I thank you. Now I need you to help us implement this modification across our entire fleet. Within weeks, Charlie found himself leading a special technical team tasked with retrofitting every P-51 inches Europe with his fuel system modification. The project received the highest priority classification, with materials and personnel diverted from other war production efforts. Charlie's modification diagrams were sent to every North American Aviation facility, and production lines were temporarily halted to incorporate the changes. As modified P-51 seconds began escorting bomber formations deeper into German airspace, the effect on combat operations was immediate and dramatic. Bomber losses dropped from the devastating rate of nearly 25% per mission to under 5%. German fighters, accustomed to engaging unescorted bombers beyond the previous range of Allied fighters, suddenly found themselves confronted by Mustangs more than 700 miles from England. The Luftwaffe has been caught completely by surprise, reported Colonel Hubert Zemke after a mission to Leipzig in May 1943. They expected our fighters to turn back at the usual point, but instead, we stayed with the bombers all the way to the target and back. The psychological impact on both sides cannot be overstated. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. Charlie's story might have remained classified and unknown if not for a chance encounter at the Inglewood plant in June 1943. War correspondent Robert Sherwood, gathering material for a feature on aircraft production, overheard mechanics discussing Garrison's miracle that had changed the air war. Intrigued, Sherwood arranged an interview with Charlie, who reluctantly agreed after receiving clearance from military authorities. "I'm no hero," Charlie insisted during the interview. "I'm just a welder who saw a problem and fixed it. The real heroes are the pilots flying these planes and the boys in the bombers they're protecting." Sherwood's article, published in the Saturday Evening Post under the title "The Welder Who Changed the War," captured the American public's imagination. Here was a story not of generals or politicians, but of an ordinary worker whose expertise and courage had made a tangible difference in the war effort. Letters poured in from across the country, including many from families of congote, bomber crews who believed they owed their loved ones' lives to Charlie's modification. The War Department, recognizing the morale value of the story, arranged for Charlie to tour aircraft plants nationwide, sharing his experience and encouraging workers to look for similar improvements. In August 1943, Charlie received a telegram from Washington, D.C. He was being awarded the Civilian Service Medal, the highest honor available to a civilian contributing to the war effort. The ceremony would take place at the White House, with President Roosevelt himself presenting the medal. The morning of the ceremony, Charlie stood nervously in the East Room, surrounded by military officers, government officials, and his own family, his wife Ellen, daughter Margaret, and son James, a Navy ensign serving in the Pacific. The president entered, and the room fell silent. "Mr. Garrison," Roosevelt began. "Sometimes the most significant contributions come not from those who give orders, but from those who see what needs to be done and take action. Your modification to the P-51 Mustang has saved countless American lives and brought us measurably closer to victory. This medal is a small token of a nation's gratitude." As the president pinned the medal to Charlie's chest, photographers captured the moment a simple welder from California being honored for what many military historians would later call one of the most consequential technical improvements of the air war. What the ceremony attendees didn't know was that Charlie's modification had already been incorporated into planning for the upcoming strategic bombing campaign. General Carl Spaatz, commanding the U.S. Strategic Air Forces in Europe, had informed the Joint Chiefs that with the extended range of the modified P-51 seconds, previously untouchable targets in eastern Germany and occupied Poland were now within reach of escorted bomber formations. "The enemy has lost air superiority over their own territory," Spaatz wrote in a classified assessment. "And they have lost it not because of any new aircraft we've deployed, but because a welder in California refused to accept that things couldn't be improved." Back at the Inglewood plant after the White House ceremony, Charlie found himself the reluctant center of attention. Workers who had previously viewed him as just another colleague now sought his advice on their own ideas for improvements. Management, recognizing the potential value in this bottom-up innovation, established a formal rapid response evaluation system for worker suggestions dubbed the Garrison Protocol in Charlie's honor. This system would yield dozens of additional improvements to aircraft production throughout the remainder of the war, from simplified control cable routing that reduced assembly time by 30% to a redesigned gun heating system that prevented freezing at high altitudes. Each innovation followed Charlie's example, practical solutions from the people who actually built and understood the aircraft, not just those who designed them on paper. By the spring of 1944, as the Allied air forces prepared for the pre-invasion bombing campaign ahead of D-Day, more than 2,800 P-51 Mustangs had been modified with Charlie's fuel system improvement. The modification had become so standard that new pilots arriving in England were shocked to learn it hadn't been part of the original design. Every textbook on aircraft design should include this as a case study, wrote Lawrence Wilson, the North American Aviation chief engineer who had discovered the modification, not just for the technical elegance of the solution, but for what it teaches us about the innovation process. Sometimes the most transformative ideas come from unexpected sources, and our job as leaders is to create environments where those ideas can emerge and thrive. The story of Charlie Garrison's modification spread throughout Allied air forces, but its true impact wouldn't be fully understood until Operation Argument, the massive coordinated air offensive against German aircraft manufacturing that would become known as Big Week in February 1944. As hundreds of B-17 seconds and B-24 seconds struck deep into the Reich with P-51 escorts accompanying them the entire way, Luftwaffe commanders realized something fundamental had changed in the strategic equation. Captured German documents would later reveal the confusion and alarm that spread through the Luftwaffe High Command. General Adolf Galland, commander of German fighter forces, wrote in a frantic memo to Hermann Göring, "The Americans have achieved what we were assured was impossible. Their fighters now appear over our most distant targets simultaneously with their bombers. Our defensive strategy, based on the limited range of escort fighters, has been rendered obsolete overnight." What German intelligence could not comprehend was that this dramatic extension of fighter range had come not from some breakthrough in engine technology or new fuel formulation, but from a simple welding modification made by a single factory worker acting on his own initiative. Charlie's return to the Inglewood plant catalyzed a transformation in how North American Aviation approached production. Plant manager Robert Davidson, who had initially been furious about the unauthorized modification, now championed what he called ground-up innovation. He established weekly forums where workers from all departments could present improvement ideas directly to engineering teams. Before the war, Davidson told industry representatives at a War Production Board conference, "We operated under the assumption that design engineers created the blueprints and shop floor workers simply followed them. Charlie Garrison taught us the flaw in that thinking. The people physically building these aircraft often understand their practical function better than those designing them on paper." This new approach yielded immediate dividends beyond the fuel system. Modification. A sheet metal worker named Rosie Mendez identified a way to reduce the number of rivets needed in non-structural panels, saving thousands of labor hours per month. Engine mechanic Frank Tillman developed a simplified oil cooling system that reduced weight by 12 pounds per aircraft, while improving reliability in high-temperature conditions. Each innovation was evaluated, tested, and when proven effective, implemented across production with unprecedented speed. The traditional months-long approval process was compressed to days through what became known as Garrison Testing Protocol, a pragmatic approach that balanced safety considerations with the urgent needs of wartime. Production. By summer 1944, North American Aviation's Inglewood plant had increased monthly P-51 production from 170 to 315 aircraft, without adding personnel or expanding facilities. The quality of each aircraft improved simultaneously, with acceptance inspection rejection rates dropping from 14% to less than 2%. This combination of increased quantity and quality caught the attention of the highest levels of the War Department. In July 1944, Undersecretary of War Robert Patterson made an unannounced visit to the plant. After touring the facility and speaking with dozens of workers, he called for Charlie to join him for lunch in the factory cafeteria. "Mr. Garrison," Patterson said as they sat with their trays, surrounded by curious workers, "what you've started here may be as important as the modification itself. This approach to production and innovation is something we need to implement across our entire war effort." Charlie shifted uncomfortably at the attention. "Sir, I'm just a welder. I saw a problem and fixed it. These folks would have done the same if given the chance." "Exactly my point," Patterson replied. "We've had the finest manufacturing workforce in the world, building our war machine, but we've often failed to utilize their knowledge. That changes now." Within weeks, representatives from every major aircraft manufacturer in America were cycling through the Inglewood plant, studying what the War Production Board now officially termed the Integrated Innovation Model. Charlie found himself reluctantly serving as the program's figurehead, demonstrating techniques and explaining the philosophy behind the approach. "The principles are simple," he explained to executives from Consolidated, Boeing, and Curtiss-Wright. "First, the people building the product understand aspects of it that designers can't anticipate. Second, every problem has a practical solution if you're willing to reconsider your assumptions. And third, in wartime, perfect is the enemy of good enough. A simple solution today saves more lives than an ideal solution next year." As the Garrison method spread throughout the aviation industry, its impact extended far beyond increased production rates. At Republic Aviation's P-47 Thunderbolt plant in Farmingdale, New York, assembly line workers identified a critical flaw in the fighter's electrical system that had caused several unexplained crashes. At Douglas Aircraft in Santa Monica, a modification to the A-20 Havoc's bomb bay mechanism doubled its reliability while reducing manufacturing time by 7 hours per aircraft. Charlie found the attention increasingly uncomfortable. "I'm not an engineer," he confided to his wife Ellen during a rare weekend at home. "These folks are treating me like I invented something revolutionary, but all I did was make a better weld joint." "That's not all you did," Ellen replied, showing him a letter that had arrived that morning. This came from Mrs. Henderson in Ohio. Her son flies a P-51 with the 4th Fighter Group. He wrote her that his entire squadron returned safely from Berlin because they had enough fuel to outmaneuver German fighters on the way home. "That's what you did, Charlie." The letter was one of hundreds Charlie would receive from family members of airmen, who attributed their loved one's survival to the extended range his modification provided. He kept each one, eventually filling a footlocker that would remain his most prized possession long after the war ended. By late 1944, the strategic air war over Europe had transformed. Bomber formations now routinely struck targets throughout the Reich, with fighter escort from takeoff to landing. Luftwaffe interceptors, once able to wait beyond escort range to attack vulnerable bombers, now found themselves constantly threatened by marauding Mustangs, regardless of how distant the target. Major General James Doolittle, commanding the 8th Air Force, summed up the situation in a report to General Hap Arnold. "The modified P-51 has completely rewritten our strategic calculations. Targets previously considered beyond practical reach are now routinely struck with acceptable loss rates. The psychological effect on our crews is equally significant. Knowing they will have fighter protection throughout the mission has improved morale immeasurably." The impact of Charlie's modification became most apparent in statistical analysis conducted by 8th Air Force operational research teams. Before the modification, bomber loss rates on deep penetration missions averaged 1.825% per mission. After widespread implementation of the modification, loss rates for similar missions dropped to 4 to 7%. Over the course of the strategic bombing campaign, this reduction translated to thousands of American lives saved. In October 1944, Charlie received a telegram from the commanding officer of the 357th Fighter Group, whose aircraft had received the first of his modifications. It read simply, 508 bomber crewmen returned today because your P-51 seconds got us home. Thank you from all of us. Charlie kept that telegram in his wallet until the day he died. The significance of the modification extended beyond the European theatre. In the Pacific, where vast distances between islands created even more challenging logistical problems, the improved range of the P-51 proved transformative. Marine Corps and Navy planners, who had previously considered the Mustang unsuitable for Pacific operations due to range limitations, now incorporated it into island-hopping strategies. During the Philippines campaign in late 1944, land-based P-51 seconds provided crucial air support for amphibious operations, flying from hastily constructed airstrips on recently captured islands to protect vulnerable transport and landing ships. The aircraft's extended range meant fewer forward airfields were needed, accelerating the overall pace of advance toward Japan. As the war in Europe moved toward its conclusion in spring 1945, military historians and analysts began documenting the factors that had contributed to Allied air superiority. Among the technical developments cited, including the Norden bombsight, H-2X radar, and the Merlin engine, Charlie's fuel system modification was consistently ranked among the most consequential. British Air Marshal Arthur Tedder, Deputy Supreme Allied Commander, noted in his assessment, "The Americans' ability to escort bombers to any target in the Reich fundamentally altered the strategic equation. What is most remarkable is that this capability derived not from some massive research program, but from the initiative of a single skilled worker who saw a better way." In April 1945, as Allied forces pressed into Germany from both east and west, Charlie received an extraordinary letter. It had been routed through military intelligence and subjected to extensive security screening before reaching him. The sender was Carl Schmidt, identified as a former technical officer with the Luftwaffe's Aircraft Evaluation Unit. Schmidt had escaped Germany as the Reich collapsed and made his way to Switzerland. His letter was both professional appreciation and personal confession. As the officer tasked with determining why American fighters could suddenly appear anywhere in our airspace, I spent months analyzing captured P-51 seconds. When I finally discovered the modification to the fuel system, its elegant simplicity left me in awe. I could not help but admire the mind that conceived it, even as it spelled doom for my country's air defense. "I write now to acknowledge your achievement, engineer to engineer," Charlie responded through secure channels, explaining that he was not an engineer but a welder who had simply applied practical knowledge gained through years of hands-on experience. This exchange would later form the basis for a post-war technical collaboration that helped rebuild Germany's civilian aviation industry. As World War II ended in Europe and then the Pacific, Charlie found himself facing an unexpected challenge: what to do with his newfound fame and influence. Offers poured in from aircraft manufacturers, automobile companies, and even Hollywood studios interested in telling his story. The modest welder, who had never sought attention, now found it impossible to avoid. After much consideration, Charlie made a decision that surprised many but seemed perfectly consistent with his character. He returned to North American Aviation, not as an executive or consultant, but as lead welding instructor for a new apprenticeship program designed specifically for returning veterans. "These young men fought the war," he explained to reporters at the program's launch in September 1945. "Now they deserve the chance to build the peace. And they bring the same kind of practical problem-solving skills to the job that helped us win." The program became a model for veterans' reintegration across American industry. Rather than treating former servicemen as unskilled labor, the Garrison approach recognized the valuable experience they had gained maintaining and operating complex equipment under the most challenging conditions imaginable. In the rapidly expanding post-war aviation industry, these veteran craftsmen drove innovation that transformed civilian air travel. Many of the reliability and safety features that would make commercial aviation the safest form of transportation originated from shop floor improvements suggested by former military mechanics and technicians trained in Charlie's program. Charlie himself gradually stepped back from daily operations, though he remained a special advisor to North American Aviation through its evolution into North American Rockwell and eventually into part of Boeing. His fuel system modification became standard in aviation design textbooks, and the Garrison method of integrated shop floor innovation was taught in business schools nationwide. In 1957, as the jet age transformed aviation, Charlie was invited to the rollout ceremony for the first Boeing 707 scheduled for commercial service with Pan American World Airways. The chief engineer insisted on giving him a personal tour of the aircraft. "See this fuel management system?" the engineer said, pointing to a complex array of pipes and valves. "It's generations beyond your P-51 modification in technological sophistication, but its fundamental principle, ensuring complete access to all available fuel through streamlined flow dynamics that comes directly from your work. We've built computers and automatic systems around it, but at its heart, it's still the Garrison principle." Charlie ran his hand along the gleaming aluminum surface of the jet's wing. "It's a beautiful machine," he said quietly. "But remember, no matter how complex these systems get, somewhere there's a worker on your line who's looking at a better way to build it. Listen to them." The most enduring legacy of Charlie's modification wasn't measured in miles of range or gallons of fuel efficiency, but in the transformation of American manufacturing philosophy. The rigid hierarchy that had separated design engineers from production workers gradually gave way to the integrated approach he had championed, a system that recognized expertise at every level of the organization. When Neil Armstrong stepped onto the lunar surface in 1969, he carried equipment manufactured under production systems directly evolved from the Garrison method. The Apollo program's remarkable reliability record, achieving the most complex engineering feat in human history with minimal failures, owed much to the culture of cross-level innovation that Charlie had helped pioneer. In his later years, Charlie occasionally spoke at Air Force Academy graduations and aviation industry events, though he always maintained that others had done far more for victory than he had. At one such event in 1975, he shared the stage with 3 retired bomber pilots who had flown missions to Berlin in 1944. "I'm often introduced as the man who extended the P-51's range," Charlie told the audience, "but that's not quite right. I just fixed a problem that kept the plane from achieving the range it was already capable of. The real lesson isn't about fuel systems or welding techniques. It's about removing the barriers that prevent us from reaching our full potential." He gestured toward the former airmen beside him. "These gentlemen and thousands like them did the real work, flying through flak and fighters to complete their missions. My contribution was simply making sure their escorts could stay with them all the way there and back." One of the pilots, former Colonel William Davidson, shook his head. "My crew and I flew 27 missions over Germany. On our 15th mission, to the synthetic oil plants at Leuna, we were hit badly by flak and fell behind the formation. 6 Mi-109 seconds came for us, and we were preparing to bail out when 3 Mustangs appeared and drove them off. Those P-51 pilots told me later they'd never have had the fuel to find us and get back home if not for some welder in California who'd fixed their planes." "So when Mr. Garrison says he just fixed a problem, well, that problem was the difference between my crew coming home or not." In 1983, on the 40th anniversary of the first implementation of his modification, Charlie was invited to England for a special ceremony at RAF Duxford, now an aviation museum hosting one of the few remaining airworthy P-51 Mustangs from World War II. The aircraft, meticulously restored, incorporated Charlie's fuel system modification exactly as he had first implemented it. As the gleaming Mustang performed a low pass over the airfield, its Merlin engine thundering across the historic grounds, the elderly craftsman watched with tears in his eyes. The pilot later presented him with a small vial containing fuel from the aircraft's wing tank. "This represents the extra miles your modification gave us," the pilot explained. "The difference between escort fighters turning back at the German border and staying with the bombers all the way to the target and home again. The difference, for so many crews, between life and death." In the decades following World War II, aviation historians and military analysts continued to study the P-51's transformation from a mediocre fighter to arguably the most effective escort aircraft of the war. While many factors contributed to this evolution, including the replacement of the original Allison engine with the superior Merlin, Charlie's fuel system modification remained a crucial element in the aircraft's legendary status. Military historian Stephen Ambrose perhaps best summarized the significance in his 1992 book, Shop Floor to Victory. In the grand narrative of industrial warfare, we often focus on the massive factories, the millions of workers, and the unprecedented production numbers. Charlie Garrison's story reminds us that sometimes the most consequential contributions come not from adding more resources, but from one person recognizing a better way to use what already exists. Charlie Garrison passed away peacefully in 1994 at the age of 94. His funeral was attended not only by family and friends, but by dozens of former airmen who attributed their survival to his work. A missing man formation of P-51 Mustangs, each incorporating his fuel system modification, flew overhead as he was laid to rest. His workshop tools were donated to the Smithsonian National Air and Space Museum, where they are displayed alongside the fuel system components from a P-51D. The accompanying plaque reads simply, "Sometimes the most revolutionary changes come from the simplest ideas, implemented by those closest to the work." The modern aviation industry, with its emphasis on cross-functional teams, integrated design processes, and continuous improvement methodologies, carries Charlie's influence in its fundamental structure. The barriers between engineers, technicians, and production workers that he helped break down have never been fully rebuilt. Perhaps the most fitting tribute came in 2003, when Boeing established the Charles Garrison Award for Innovation, presented annually to a non-engineering employee whose shop floor improvement significantly enhances aircraft performance, safety, or efficiency. The award criteria specifically note that recipients should demonstrate the courage to challenge established procedures when a better method becomes apparent. 2. Today, advanced fuel management systems in everything from commercial airliners to military jets incorporate principles first demonstrated in Charlie's simple modification. Computer-controlled systems have replaced manual valves, and composite materials have supplanted aluminum, but the fundamental approach to ensuring complete fuel utilization remains rooted in his insight. In aviation museums around the world, docents telling the story of the P-51 Mustang invariably mention the modification that transformed its operational capability. Some even demonstrate the difference using cutaway models, showing the before and after configurations of the wing-fuel junction. For pilots and aviation enthusiasts who understand the technical details, the elegance of Charlie's solution still inspires admiration, not just for what it accomplished, but for how it demonstrated that sometimes the most effective innovations are also the simplest. In 2015, a documentary filmmaker located the footlocker, containing the hundreds of letters Charlie had received from families of airmen. With permission from the Garrison family, these letters formed the emotional core of the film The Extra Miles, which introduced Charlie's story to a new generation. One letter, read aloud in the film by the son of the original writer, captured the human impact of Charlie's work. "Dear Mr. Garrison, you don't know me, but my husband, Lieutenant Robert Keller, flies a P-51 with the 354th Fighter Group. Last week, his squadron escorted bombers to Berlin. On the return, they encountered a large formation of enemy fighters. The ensuing battle scattered their formation and consumed far more fuel than planned. Robert told me that in the old days, he would have been forced to ditch in the North Sea. Instead, he made it back to base with your modified fuel system. Our daughter was born 3 days later. She will grow up knowing her father because of you." The film concluded with footage of modern aircraft manufacturing facilities, where production workers and engineers collaborate in real time to refine designs, the direct organizational descendant of the revolution Charlie helped start. The final shot showed an elderly veteran running his hand along the wing of a restored P-51, his expression conveying what words could not. Some technological advances change more than machines, they change lives. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.